So answering my own question from the previous video, why is it that as we rotate this family of equilaterals and I draw the antipedal with respect to a point P, in this case P is on the circumcircle, you can see here that when the vertex of the equilateral goes through P, the antipedal shrinks to a point, but then there is this mysterious location here where the antipedal goes unbounded, right? It goes unbounded, and then it undergoes this eversion. And I was trying to figure out why that was, right? And it turns out, if you actually draw the so-called midlines, which are lines that basically here is the medial triangle of my reference, and then you just extend the sides of the medial triangle. It turns out that if, for any triangle, okay, if the anchor point P or the pedal point P, if either one of these midlines passes through P, the antipedal triangle is unbounded. So let's look at that. So you can see here that now the antipedal triangle is safely bounded, but if I rotate my family in such a way that now P is contained in one of the midlines, you can see here that the antipedal is starting to get unbounded, right? And then when P is exactly on the midline, and I'm actually going the opposite direction, I'm rotating this guy a little bit. When P is exactly on the midline, one of the vertices of my antipedal triangle is actually in the line of infinity, not defined in the real plane, and after you pass that, it actually undergoes this eversion. So you're having this sort of transition here. And how many transitions there will be? Here's another one. So there's a second one, and then there's a third one, a fourth one, and so forth. So for a triangle, you're going to have 6 transition zones. And for the equilateral, the interesting thing is that they don't have the same angular separation in terms of rotation of the equilateral. Okay. Now, of course, if I don't have an equilateral, I still have the same idea. I can draw the medial triangle. Okay. And this is for any triangle that obtuse, acute, so long as P, my anchor point, is not on one of the midlines, my antipedal triangle is bounded. Okay, but in case of P being on one of these midlines, you go through the same issue. You can see here that P now is pretty extended toward the right, correct? Sorry, the triangle is pretty extended toward the right, and as soon as I cross over, then it flips, it undergoes an eversion. So graphically, I actually made a few drawings here. I'm going to share these drawings with you guys. Here's what you get. You get the sort of midline, symmetric midlines for the case of the equilateral. This has nothing to do with our problem of rotating equilaterals. It's just something that is inherent to triangles. So anywhere P is going to be in one of these midlines, the antipedal is going to be unbounded. Here I have distorted the triangle a little bit, and I'm showing the midlines as well. So these are forbidden zones for P. And here's another picture of a yet more distorted triangle. Okay, so this clarifies a question that I had posed in the previous video. See you on the next one.